final opportunity. And I understand this is over Thanksgiving break. I understand that. Um, it's not one of these 48-hour exams, okay? It's not. It shouldn't take you more than 2 or 3 hours to complete, 4 hours if you take your time. Okay? So, I really don't think it's gonna put a huge dent in your Thanksgiving break plans. Really
What
don't.
what even are the official dates for Thanksgiving break? Because I don't actually remember.
LCC or Toledo?
LCCC. I'm not taking any Toledo classes this semester.
I think it's only Thursday and Friday of next week, right? Right, guys?
Okay, that's what I figured. I just want to double check.
And the student council or student, God, my daughter was president of it. Student something or other. I can't remember what. Um, Student senate, maybe. Okay, they put on a Thanksgiving bash Wednesday evening, and you get a free meal out of it. It's open to the community. I assume they're going to do that this year. Certainly hope so. Um, it's it they do it right. If you've been to one, you know exactly what I'm talking about. Okay. Um, are you guys ready to roll?
Yeah.
Is it okay? Um, Today I promised you a different type of problem, um, but a joint probability distribution. It's continuous again. Okay. And you guys ready to roll?
Yeah.
Okay. This one's based on. I could change it, I guess, but I kind of rather not. Because right now I can't think of anything right off the top of my head that's totally jumping out at me. Um, what variables? Can we have M here? Uh, Here, suppose a bunch of runners. Is anybody a runner? Well, I am not a runner. Personally, I believe that, well, for me at least, running is a form of punishment. Okay. So why would I inflict punishment upon myself? Have you ever seen a jogger with a smile on their face? Long distance runners look like they're dying, don't they? Right? Then why do you do it? Oh, oh, I see. Oh, I'll buy that. I'll buy that. When you get to be in your 30s and 40s, and you start, packing on a couple of pounds that you didn't have when you were 20. Um, there's some guys that run so they can eat anything they want, and that's pretty much a direct quote. Um, okay, so we got a bunch of runners that participated in a marathon. Okay, the fraction of the guys that complete it is a random variable. What do you want to call it? We're going to have guys and gals, men and women, males and females. Give me
M and
shout out M and F. Okay.
M and
Random
F.
variable M. Random variable M with 0 less than. I hope this is totally obvious to you because it's a fraction. It's going to be between 0 and 1. Right? Right, guys? Talk to me. If it's a really easy marathon, then M is going to tend towards 1, right? Conditions are perfect, blah, 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 right?
Yeah.
If it's an incredibly difficult marathon with horrible conditions and high winds going uphill both ways, that kind of thing, M might tend to decrease quite a bit. Fraction of gals. Is, you said F, correct?
Yeah.
Well, the fraction of gals can go 0 to 1 as well. Now, historically, um, 0 less than or equal to F less than or equal to M less than or equal to 1. Historically. What is this last statement telling us in English, guys?
Females are slower than males.
I'm not sure I'd put it that way. But yeah, you're on the right track, right? How about more males finish than females? Can we phrase it that way?
Oh, I thought this was racing times. I just showed up.
Oh, no. This is the fraction of runners that complete the marathon.
Oh, got it. My bad.
No problem. Okay, now I understand. I'm like, Brian, did you seriously just say that?
Oh, thank you.
What would Kirsten say? Kirsten, right?
Yeah, Kirsten, what would you say?
Guys are faster than girls. That's basically what Brian said, isn't it?
She said I am faster than her.
I think that's like word for word what he said.
Statement.
What'd she say?
I'm reading what he put on the board. Don't look at me like that.
So, I saw a special on TV or something like that about the Olympics or whatever, and the marathon for females wasn't even a thing until I think the 60s or maybe 70s, because they didn't think a girl could finish a marathon.
Okay, that's pretty bad.
What's that? Well, theoretically, back in ancient Greece, right?
But the modern Olympics started in like
1896.
Yeah.
1896, and I think they had the marathon that year. Okay. So, the historical data shows that f of x comma y, the PDF, joint PDF of x and y equals a x y for 0 less than or equal to, well, here, I think we can actually sum everything up with this, can't we? This inequality sums everything up. And it also grabs the relationship between M and F. So 0 less than or equal to F, less than or equal, we don't have to write the equalities, do we? Right? Okay. So F is always less than or equal to M. Or vice versa, M is always greater than or equal to F, and both are 0 to 1. Okay. And of course, the density function is 0 elsewhere. I hope it's obvious to you. I hope it's obvious to you that this function, AXY, is not linear, and therefore, if you look at it in 3D space, it's not going to be a nice, neat, what, a four-dimensional, what's a tetrahedron, right? Except for the sides aren't the same. It's not going to be a plane in the XYZ space. It's not. It's going to have curves. Okay. Does that make sense, guys? Yes, no.
This is
Yeah.
the intersection.
I'm sorry?
This is the intersection that it makes.
The surface is probably, we'd have to run some numbers to figure it out, but the surface is probably something like this. Because if you remember a hyperbola, something like this, right? Where it asymptotically approaches 1 or 0, and it asymptotically approaches 1 here. And it's probably something like this in the XY plane. That's just a guess, guys. I don't know. Okay. But I guarantee these are not going to be straight lines. I can guarantee that. I should run some numbers and figure that out. All right. So, ready to roll, guys? We're going to find A. We're going to find the means of the two random variables, M and F. We're going to find standard deviation of M, standard deviation of F, and we can change these numbers for the probabilities if you wish. It's up to you. And this, of course, is the covariance and correlation coefficient are terms of the random variables M and F in this problem. You guys ready to roll?
Yeah.
Talk to me. What's the first thing we got to do, guys?
The board's a bit fuzzy, Professor.
Oh, crud. I know why. Startup procedures, right? I need some. Sorry about that, guys. I should have fired it up before. Yeah, maybe we should. Just hit a little button and it fires Discord up, and then camera app and Logi and all that. Okay, you guys ready to roll? By the way, did it come back into focus?
Yeah, that's better.
Okay. Can I get rid of our opportunity, please? Yes, no? Talk
yeah,
to
I
me.
already took a screenshot of it and placed it in
Oh,
statistics
okay.
chat.
All right, cool. Who was that? Was that Chris?
No, that was me, Liam.
Liam. Okay. Okay, you guys ready to roll? What's the first thing we have to do before we do anything? Don't we have to find out what A is?
Yeah. I thought
Right.
you were trying to say before we find A.
No. Well, To find A, what do we have to do? We have to integrate, right?
Yes.
What do we integrate? I'll spot you the integral. Singular, double.
Double.
Has to be a double because we have to integrate over F and M. Okay, so we're going to integrate the PDF, right? AXY.
Yes.
Do you want to do dx dy or dy dx? I'm sorry, df dm or dm df. And this is not AXY, it's A M F. A is a constant, F and M are the variables. So which one is it? What do you think? Where's the
DM.
strong? DM, DF. Okay, what are the inner limit? The outer limits is 0 to 1. I hope that's obvious.
Yeah.
Because after the first integration, one of these variables goes away on the inequality. So what are you left with? Whatever's left is between 0 and 1, right? So what are the inner limits if we go DM, DF?
1 minus.
Careful. Do you really want to subtract? Don't you see that M is between F and 1?
Okay.
Do you buy that?
Yeah.
So M will always be greater than or equal to F, and it will always be less than or equal to 1. Okay?
Okay.
Do you buy that?
Yeah, that makes sense.
Does everyone buy that? What would we get if we flipped the limits? Or if we flipped the order of integration? What if we integrated with respect to F first?
Then it
What
would
would
be,
be the
between 0 and M.
right? So which is better?
0 and M. Because that
Yes.
falls out.
Does everybody understand that? This is better if we integrate with respect to F first because the lower bound's 0. So when we subtract the lower bound out, once we integrate, when we subtract the lower bound out, more than likely it's going to totally go away. Do you see that, guys? So, everybody, I hope. Okay. Are they really discontinuing the CSET program? There's been rumblings of that for a few years.
That's what I was told. I've
Really?
had to find a different program.
And this is Liam or Chris? You guys have similar voices.
This is Chris.
Chris, which program are you in then, Chris?
I'm in CSET because I can't do in class or in person class.
I
So
see.
it was
I
my
see.
only
I
option.
see.
But now I'm
Okay.
going to WGU next semester.
Western Governors University. Okay.
I'm kind
Well, I'm
of
sorry.
stuck with a online option. I got a career.
No, I understand that. I totally get it. I don't know. Yeah, no, I totally get it. They haven't supported the CSET program well for a decade. And then we'd get CSET students that come into some of our classes as juniors, and they haven't had the foundation. And it's a real struggle for them. It's really sad because, I do my best to help them, but anyway, okay.
When I was told
Let's
about
do-
the CS, this new CS program by one of my advisors, she said that like a lot of the classes might transfer from CSET and it wouldn't be that bad to just do that instead.
CSE or CSET?
CSET to CS, the new CS degree that they're going to be replacing CSET with.
Oh, I see. Yeah, I don't know what CS is going to be. I thought it was going to be more programming algorithms and languages.
Yeah, because I mean, honestly, in the end, like that's really what I personally care about more is like programming rather than like engineering as a whole. I like to program a lot, so
Okay, then it suits you.
that's why I feel like CS moreover suits me. My only problem is I don't want to waste all this time. I've already spent like 4 years. It's bad.
Yeah. I'm not sure education is a waste of time.
Well, no, I'm saying it's not like it's. I'm not saying education is a waste of time. I'm saying that
I know
I'm
exactly.
wasting my time because I have spent over the 4 years. Now this is like my 5th year, I think, because I was doing a minor, and also which I have since stopped doing because I don't have the time for that, and also failing my math classes. So. And also doing internships, which all 3 of those things take time away from potential 4-year completion of your degree.
Yes, they do. There does have to be an end in sight. I wholeheartedly understand that. Okay, so we integrated this AMF with respect to F, right, guys?
Yes.
So the F goes to F squared over 2. You buy that? Because A and M are both constants when we're integrating with respect to F. So what do we get out of this bad boy? Don't we get AM cubed over 2? When we plug 0 in, that's just going to disappear. So plug, and this is F equals M and F equals 0. Sorry about that. I should have written it that way. So we plug M in here for F, you're going to get AM cubed, right? Because it's going to be AM times M squared, so AM cubed over 2, right? Minus, of course, 0. Do you buy that, guys?
Yes.
Talk to me. Well, this isn't too bad, is it? I get AM to the 4th over 8. Evaluated from 0 to 1. Do you buy that, guys? Talk to me.
Yes.
And that's simply going to be AM to the 4th. AM to the 4th over, actually this is capitalized because it's a random variable, not a specific value. And this, we set this equal to
1.
1. What does that mean A is, guys? Oh, timeout. It's not AM to the 4th. If you plug 1 in here, that's just A over 8. So A equals 8, yes, no?
Yes.
Okay? No smoke and mirrors, no magic. Which for some of my calculus classes, I swear that's what was going on. Sam Butler calls it sorcery. Okay. I'm not sure he's wrong. But the day Jeff Ziegler shows up in a wizard's costume, that's gonna confirm it for me, right?
I can see him doing that.
Yeah, I can too. I can see Katie Dobek showing up in a witch's costume too. I can totally see that. Okay, go. I know. Okay, how about if we find the mean, guys? Ready to roll?
Yep.
Okay, how do we find the mean?
You calculate the expected value of M and also the expected value of F.
And how do we do that?
Uh,
The only thing we have is the PDF of both variables.
are we able to separate it?
How do we separate them?
I don't remember.
Well, we need two different functions, right? One just having M in it and the other having just F in it, right?
Right.
Doesn't that sound like a marginal kind of thing? Finally, got rid of that smudge. I really like to know what causes that. So we have f of m comma f equals 8mf 0 less than or equal to f less than or equal to m less than or equal to 1, 0 elsewhere. Okay? Do you remember we have to find, in order to get anything else in terms of just m or just f, what we have to do is we have to generate the marginal functions.
Okay.
Do you buy that, guys? Talk to me. Yes, no?
Yes.
So I'll do them up here. If you want to follow along, you are more than welcome to. In fact, encouraged to. If you think you can do it on your own and want to compare notes at the end, that's fine too. Okay. Brian, it's not fair asking Kirsten what the answers are, okay? That's cheating. Okay? Just saying. And Chris, you're not allowed to ask your wife either.
Got it.
She gave me a look like she does know the answer.
She probably does, Brian.
She usually has all the answers.
Of course. Here's the limits of f, guys. 0 to m. However, you are allowed to ask the dog. We had a farm dog a few years ago that I swear he could do calculus. God, he was smart. Yeah. To find h of f, you integrate the m out, right? And m goes from f to 1. So it's not going to be quite as clean as the one we just found. Wait a minute. What did I screw up? I screwed something up. This is 8. This is 8f, not 8m squared. 4f. This is 4f. Okay. And you plug f in for m here. Is it 1 minus f cubed?
F squared. Well, in the parentheses, it's 1 minus f squared.
Because
Yeah.
we got one out here. That's right. Yeah. Thanks, guys. Very much. And this, of course, has limits. Maybe I do need the dog. So these are the marginal distributions of G of M, and H of F, okay? So we can write these up here. I'm going to choose a different color to stand out a bit. How about purple?
Nice.
I guess we could do, well, I started everything in blue. We can do blue and pink. Blue for the guys. How about dark blue for the guys and pink for the girls? How's that? How's that for a stereotype, right? Okay. So now we have to find the means, right, guys?
Yes.
Can I get rid of the work for G of M and H of F? Can I get
Yeah.
because we found the functions going once, twice. So what's the mean? Well, it's the
So-
expected value of M. Go on.
I was going to say exactly that.
The expected value of anything is the integral of
Anything times the function.
and the bounds, since we integrated F out, the bounds go from 0 to 1. So that's a good thing, right? I get 4m to the 5th over 5, right? Because you're going to get m cubed, right? You're going to integrate 4m raised to the 4th power. So it's going to be 4m to the 5th over 5, 0 to 1. What do you get out of that?
4 over 5.
Mm-hmm. It looks a lot nastier than it is with that, a variable raised to the 5th power. But you don't have anything else, so it's just plug 1 in and that big nasty 5th power just totally goes away, right? What do you think mu sub f is? Don't we just do the same thing, but use everything for f?
Yep.
But this time, we have to use h of f instead of g of m, right?
Yes.
Okay. Not quite as wonderful as and simple as, boy, I could make a really sexist remark right now, but anyway. The calculation to find, excuse me, that's God punishing me for that. The calculation for f is going to be a bit more involved. It's going to be a bit more complicated, okay, than it was for m, because you're going to have inside these parens, you're going to have 4f minus 4f to the 3rd power, and of course you multiply that bad boy by by f, and you're going to get 4f squared. This is what we're going to integrate, guys. Minus 4f to the fourth power. That's what we're going to integrate. Okay, you ready to roll?
Yep.
It's really not horrible. It's doable. So we have integral of 4f squared is 4f to the third over 3, integrated from 0 to 1, minus 4f to the fifth over 5, right?
Yes.
Okay. See, it's not horrible. It's 4/3 minus 4/5, is it not? Yes, no?
Yeah.
Yep.
Okay. Lowest common denominator is 15. So multiply 4/5 by 5. Multiply 4/3 by 5. Multiply 4/5 by 3. And you get 8 out of 15. Does this match the math, gentlemen?
Well, the mean for F is smaller than the mean for M, which makes
Does that
sense.
match? That makes sense given the inequality, does it not?
Yeah.
So we don't know that they're right. Actually, they are, guys. That is right. That's what I have in my notes, at least. So it matches what we're given. Okay. All right. So we figured out what the means are. Are you ready for the variance?
Yes.
Because to get the standard deviation, we need the variance. Yes, no?
Correct.
Can I get rid of our work to do to find the means of the two variables?
Yeah.
Going once.
Yeah, I got on the board.
Okay. $4.45. Okay. Oh, man, my knees are killing me today. Variance sigma squared. Sigma sub m squared equals. Do I have a better dark blue marker? Let's try this one. This one appears to be dying. I think it's better. Isn't the yeah, it's much better. Expected value, excuse me, of m squared minus mu sub m quantity squared. Yes, no, guys?
Yes.
Okay, how do we find the expected value of m squared?
Integral of M squared times G of M.
What are the bounds?
0 to 1.
Don't forget the minus mu squared, guys. So minus 16 out of 25. Yes, no?
Mm-hmm.
Right? What do you get, guys? This is going to be 4m to the fifth, and we got to integrate it, so it's 4m to the sixth over 6, 0 to 1, minus 16 out of 25. What do you get? Did I do that right?
Yes.
4 out of that's really 2/3. So 75's the least common denominator. This is 2/3. So it's 50 minus 48 all over 75. Check my math, but I'm pretty sure that's right.
That is right.
That means sigma m equals square root of 2 over 5 radical 3. Make sure I'm right on that too, guys. But I'm pretty sure I am. Do you buy that, guys?
Um,
Did I screw something up?
no, I think that's right.
What
I
I
think
got.
so too. I think so too. All right, cool. Cool, guys. How do we find sigma squared f? Well, how do we find sigma f? We got to find sigma squared and then take the square root. How do we find sigma squared of f? Isn't it the same thing, only different?
I mean, that's pretty much right.
Yeah. I think that's a Yogi Berra quote, but don't quote me on the Yogi Berra quote. You guys know? Oh, does anyone in the class know who Yogi Berra was? He might have. I think he passed away. Anyone?
Wasn't it a baseball thing?
Yeah, he was a
I-
baseball. I think he was a catcher. I think for the Yankees. I know he played for the Yankees, but he was famous for his yogi sayings. You know, it ain't over till it's over, right? um. Oh, there's a ton of them, and I can't think of any of them. I think it's the same thing, only different. 90% of this game is half mental,
Yeah.
stuff like that.
Yeah.
You can't argue with them, but it's like, well, I didn't never thought of putting it that way. So, what's the integrand going to become, guys?
You forgot to subtract your mean.
Mu sub f squared. So 8 out of 15 is 64 out of 2 1/4. That's going to get ugly, right? Pretty sure that's right. So what's the integrand? What are we really integrating? This is 4f minus 4f cubed. There's a famous Aflac commercial. Do you guys need a brain break?
Why not?
Let me see if I can find it. You guys integrate this and tell me what you get, okay?
Yeah.
While I look for it. All right. If it's way off in left field, I'm probably gonna notice it. You guys have seen the Aflac commercials, right?
Mhm.
Um, Okay, can you see it?
Yeah.
Not too close. What do you think? I got
Why we don't have sound? Why not?
the one you
Have you
really
Because
got
of
need to
this.
have. If you don't have
You do,
it,
you have sound? I don't have
that's why you
Yeah.
sound.
need it.
Need what?
Well, if you get hurt and miss work, it
You
won't
guys
hurt
can
the
hear. I
next
can't
week.
hear anything. It's
Yeah, I can hear it.
And they give you cash, which is just as good as money.
Aflac. Ask about it at work.
Not too close. What do you think?
Why can't
got
I
that
hear it?
insurance.
Oh, because Discord's running.
The one you really need to have. If you don't
But
have
I
it,
remember that.
that's why you need it.
Need what?
Well, if you get hurt and miss work, it won't hurt the miss work.
Okay,
And they give you cash, which is just as good as money.
back to class. Did that rest your brains for a little bit?
Ask about it at work.
Yeah.
Okay. We have to change the screen.
That face that is usually covered by her phone has finally made
What'd you guys get? Anyone finish it? The integral?
Well, I have sigma f.
What's sigma f?
I got square root 11 over 15.
Trying to remember if that's what I got. I don't have my notes out yet. Anyone else get that?
I'm not done with it.
That's what I got.
So you integrated and you got f to the fourth minus 2/3 f to the sixth. Yes, no?
Yes.
So that's going to be 1 minus 2/3, which is 1/3. So you're going to have 1/3 minus 64 out of 225 for sigma squared, right?
Yes.
Right. This 1/3 is really 75 out of 225. Okay. All right. And that's where you get the 11, right?
Mm-hmm.
Because you subtract 64 from it. Okay, guys? So it's square root of 11 over 15, because the square root of 225 is 15. All right? That's how you get sigma f. Okay, guys? Are there any questions on that?
No.
Ready to find some probabilities?
Yes.
Everyone else? Talk to me.
Yep, I'm ready.
Okay. I kept the values the same. If nothing else, then just simply to show, what the effects of the actual function are, and the fact that the bounds have a different meaning as what we had before. So the probability that 0.5 is less than or equal to m, less than or equal to 3/4. I should just say 1/2, right? Because that'll make it more obvious what's going on. We just integrate g of m, guys. From 1/2 to 3/4 is the area under the g of m curve. And this is going to be m raised to the fourth. It's 4m raised to the fourth over 4. The 4's cancel. And this is from 3/4 to 1/2. And I get, nothing's going to drop out or anything, guys. 81 over 256. Did I do that right?
Yes.
And 1/2 raised to the 4th power is 1/16, which is 16 over 256, right? I get 65 out of 256, unless I screwed something up, which is totally possible. Did anyone else finish it and get a different number?
No, that's what I got.
Okay, cool. All right, moving ahead, the probability. Okay, here's a question for you guys. What's your gut say? Probability of 1/2 to 3/4, so 1.25 range that we're integrating over, and we got 65 out of 256, which is about what? About a quarter ish, 25%, right? 25% chance that 1/2 to 3/4 of the males finish. What do you think the probability for 1/3 to 2/3 of the females finishing is? Do you think it'll be like way higher, way lower, somewhat close? What do you think?
Well, it's kind of interesting because you get a larger range,
Yeah,
but less females finish.
but we're also dropping the lower bound too, though, right, Brian?
Yeah.
In other words, we drop the entire range for the female. I bet it's going to be somewhat similar. You know, it's not going to be a factor of 10 higher. It's not going to be a factor. Well, it can't be a factor of 10 higher. It's not going to be, factor of 3 higher. I don't think. And it's probably not going to be way, way, way lower either. I'll bet you it's comparable. We'll find out. Sound good?
Yeah.
Okay. Multiply it out. We're really integrating 4f minus 4f raised to the 3rd power. That's what we're integrating. Integrate that bad boy. I'm going to pull the 4 out. No, I'm not going to pull the 4 out front. You're going to end up with 2f squared, I believe, from 1/3 to 2/3 minus f to the 4th, right, guys?
Yeah, 2f squared.
2f
Yeah.
squared, yeah, because it's 4f squared over 2. So it should be 2 times the quantity, square it, 4/9 minus 1/9 minus, oh boy, 2/3 squared. That goes to 16 out of 81 minus, is that right? Yeah, that's right. Minus 1 out of 81, I believe. Make sure I did that right, guys. I think I did. Four ninths minus 1/9 is 3/9, which is 1/3. This is 15 out of 81. Is this step right, guys?
I did not get 1/9, but I could have done it wrong.
Did you distribute the 2?
Oh, no, you're right. Never mind.
So 1/9 is correct for the lower bound of the first
Yes.
term? Okay. This is 15 out of 81, which is 5 out of 27, right? And lowest denominator is 27. So you multiply that bad boy by 9 minus 3. 9 minus 5 is 4 out of 27. I didn't think it'd be that low, guys. Numbers don't lie, though.
Shouldn't it be 13 out of 27?
Oh, I'm a total idiot, aren't I? Yes. That matches what I would think. Pretty close to half, right?
Yeah.
Like, very close to half. So, comparable and higher. And
Twice as much.
twice as much. Does that match? Does that, looking at the answers now and looking at the mean values and the ranges, does that match your gut? Does that make sense to you?
I would have believed it either way, honestly.
Well, this range, the mean value of F, 8 out of 15, that falls almost right smack dab in the middle of this range, 1/3 to 2/3, right? It falls almost right in the middle. So we're integrating probability mass around the mean value. So with a continuous function, that really makes sense. With M, we had a much lower number, half of what we got for the second one. But notice
And you
that,
don't hit your mean either.
right, exactly. The mean is 4/5, 0.8. We haven't even integrated up to the mean yet. So these numbers make sense, guys. They do. And I hope you see that now, if you didn't before.
Yeah, that helped.
Okay. Ready to do the double integral, guys? Talk to me.
Yes.
That means I can get rid of this, I think, right? At least this.
Yeah.
Now remember, with the double integral, we're placing two bounds. We're placing guys and gals. But we're also adding, because we're finding the volume under the surface instead of just the area under the curve. So I guess I will switch to teal. I guess I could go to black or real gender neutral. Anyway, probably. So we got this, right? And the females is 1/3 less than F less than 2/3. Okay. And this is just the double integral, right, guys?
Yeah.
Which one do you want to integrate first?
Let's do M.
M first?
No, let's do F first.
Anyone have any objections to that? I honestly don't know which is going to be simpler, guys. We're going to have an F squared. So we're going to have terms involving something over 9. Yeah, probably not too bad. Okay. So integrate with respect to F first. And that means the outer integral goes along for the ride. So this is going to be 8m f squared over 2, which is 4m f squared evaluated from f equal 1/3 all the way up to f equals 2/3 dm. Okay? So we have 4m, because m's a constant, times 2/3 quantity 2/3 squared minus 1/3 squared. Yes, now? You buy that?
Yes.
So what we had before, 4m, this is going to go to 1/3, guys, because 2/3 squared is 4/9 minus 1/9 is 3/9, so it's 1/3. So we're going to end up in the outer integral is going to be 4m over 3. Okay? dm, and m goes from 1/2 to 3/4. Okay? So it's going to be 2m squared over 3. Okay? You're going to get m squared over 2. So you're going to have 4 over 2, which goes to 2. Evaluated from 1/2 to 3/4. And this is going to be 2/3 of the quantity. 9 over 16 minus 1/4. Is that right?
Yeah.
And the stuff inside the parens, does that go to 5 out of 16? Yes, no?
Mm-hmm.
So 2/3 times 5 out of 16. So you get 10. Well, the 2's can't, that becomes an 8, guys. So it's 5 out of 24, right? Right?
Yeah. Yeah.
Yep.
So that's roughly 1/5, right? About 20%, a little higher, but less than this number up here. Certainly less than this number here. Okay. All right, you ready to find covariance?
Yes.
Okay, guys, here we go. How do we find covariance?
The expected value of MF minus the mean of M times the mean of F.
Very good. Good job. So sigma xy equals expected value of xy minus mu sub x, mu sub y, right? How do we find the expected value of xy? The expected value of anything is the integral of anything, right? Times, what are we integrating? This is xy, so it's got to be the whole joint probability density function, right? Oh, not xy. Why didn't you guys catch me?
I was looking at that. That was a little.
Yeah, like, don't we have different random variables? Yes, we do. So it's going to be m times f times 8mf. You want dm, df, df, dm. What do you want?
Let's do. We did DFDM before.
We did.
Yeah. So
You
let's do
think
that
that's
again.
the way to go? Yeah, I think it's the way to go here too, right? The integral's not going to be any simpler. So having that zero bound inside really helps. Okay. And we're doing D, integrating over the gals first, then the guys. Okay. And I hope it's obvious to you that this is going to be 8m squared f squared, right? That's the function we are integrating.
Yes.
Yes, now? So you integrate that with respect to f, you're going to get 8m squared, that's a constant, remember that, over times f cubed over 3, with f equaling 0 at the bottom and f equaling m at the top. Okay? So plug them in. What do you get? Don't we get 8m squared times m cubed? All over 3 minus 0. The lower limit goes away. And this is dm, yes, no?
Yeah.
So now we got to enter. Oh, and shame on me. I forgot to subtract off the product of the means. Well, here, I can fix it this way. We just have to do it at the end, okay? How's this for trickery? We have to subtract off the product of the means from what we're finding here, guys. Okay? So what do we get? What's the integral of 8m to the 5th over 3? Yes, no?
Yes.
Which is 4 over 9, right? Do you buy that, guys?
Yeah.
So therefore, sigma sub m f covariance equals 4/9 minus the product of the means, guys. Can't forget that, can we? So it's square root of 2 divided by 5 radical 3 times square root of 11 over 15.
Those are the standard deviations.
Oh, crud. We're going to need those for the... My bad. I looked at the wrong... Yeah. I wonder why we had so much square root stuff in there. Did I get that right? I think I did.
Yes, you did.
Okay. The least common denominator out of all this stuff is 225, guys. Sorry. You would think it'd be 75 because 5 times 15, but 9 doesn't go into 75 evenly. You got to go all the way up to 225. Okay. So this is going to be 100 minus, because you got to multiply the 9 by 25. You got to multiply this stuff up here by 3 to get it over 225. That's going to give you a 96 upstairs. So it's going to be 4 out of 225, right?
Yes. That's what I got.
Okay. And what's the correlation coefficient?
It's the standard or
Covariance.
covariance divided by the standard deviation of m times standard deviation of f.
Wow, try and say that 5 times fast.
Yeah, I'm not even gonna
What-
try.
Well, this stuff down here flips up top, right? And that's going to leave us square root of 22 downstairs. Okay. 15s cancel. Well, not all the way. This cancels, leaving us with 3. So what do we have? 4 radical 3 over 3 radical 22. You get some number out of this. I don't remember what it is. I can check my notes and see what I got. What did I get? Dun, 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 dun. Did anyone figure out what that value is exactly? I got
I have 12 radical 3 over square root 22. Where'd you get 3 square root 22?
I did some 4 times
I
square root
see.
of 3. This 3 comes downstairs, of course.
Yeah, I moved my fractions wrong.
And I'm not sure I found. Oh, yeah, I did. So did I find row? Oh, I screwed something up. I got that. I got that. Did I get that? Oh, yuck. Yeah, I didn't find row, unfortunately.
I got a decimal that's around 0.4923 ish.
About 1/2. Does that match your gut about the strength of the relationship between M and F? For one thing, we know it's positive, don't we? What is positive? Positive covariance, positive correlation coefficient. What does that mean?
When one increases, the other increases.
Right. So when and does that match your gut? If the fraction of guys increases, is the fraction of girls that that finish, is that going to increase as well? Doesn't
Well, that
that?
increases, like it shifts the bounds that the F is limited by.
Yeah, but does it match your gut? If in a particular marathon, if the fraction of guys tends to go up because the conditions are really good, doesn't that mean the fraction of girls will probably go up as well?
Mm-hmm.
And right, the opposite's also true. If the fraction of guys, due to really horrible conditions or whatever, the fraction of guys goes down, the fraction of girls is going to go down as well. And that's what the sign of this value. Sorry, the sign of this value is telling us it's positive. Okay. Now you take all the fraction stuff out, and we see that it indeed is pretty high. So there's a fairly strong correlation between guys and gals, and that should match your gut, shouldn't it? I mean, it's not a dead giveaway, but I mean it's showing that it's a fairly strong relationship between the fraction of guys and fraction of girls, right? Does that make sense, guys? Everybody?
Yeah.
Okay, we're a couple minutes over. Are there any questions?
This upcoming opportunity, that's not the final, is it?
No,
Okay.
no. The final's going to be probably given to you the Friday after this Friday after the first Friday after Black Friday,
Okay.
because I think that's the end of regular classes. All right.
All right.
Okay, guys, have fun. Take
Thank you.
care. All right. Bye bye.
Have a good
You too.
Have a nice day, Professor.